All right, let's try example 2. I want us to convert r equals 3 cosine of 2 theta to rectangular form. Okay, so what we want to do here is use our toolbox. Okay, again, r squared equals x squared plus y squared. Uh, r cosine theta, that's equal to x. R sine theta, that's equal to y. And then we know tangent theta is y over x. Okay, so we have r cosine theta on the left-hand side. I'm sorry, in our toolbox. But for the example, we have 3 cosine of 2 theta. So in the toolbox, it says theta, but in the problem, we have 2 theta. So how can we get this cosine of 2 theta to look like just a cosine of theta or a sine theta? Very good. We can use our double angle formula, whichever flavor you choose. Okay, and then, okay, so then we can substitute. Instead of cosine of 2 theta, we know that that's equal to cosine square theta minus sine square theta. I could have used any flavor, but we're going to go with this one because I can use my toolbox. I can use cosine theta and sine theta. Okay, and if you want to add to your toolbox, it's true that if x equals r cosine theta, then x squared is equal to r squared cosine theta. I'm sorry, cosine square theta. And y squared equals r squared sine square theta. That's just multiplication. That is something that we already know. You don't have to add it to your toolbox, but these are facts. So what's missing then? So step 1, I use my double angle formula. To get everything in terms of cosine theta and not cosine 2 theta. And then step 2, now we can do what we did with the last problem, and we're going to multiply both sides by, let's see, if I multiply both sides by r, then on the right-hand side, I have 3r cosine square theta, and that's not something I can convert easily. So instead, I can multiply both sides by what? Very good, r squared. So on the left-hand side, multiply by r squared. On the right-hand side, multiply by r squared. And you want to distribute that. Now I have something that I can convert. Now I'm ready to use my toolbox. Now I can take r squared cosine square theta and substitute that with x squared. And I can take r squared sine square theta and substitute that with y squared. So on the left-hand side, I have r squared times r. On the right side, I have 3x squared minus 3y squared. I'm almost there. So if r squared equals x squared plus y squared, then r is equal to the square root of x squared plus y squared. So I can put that back and substitute back into r. So now I have r squared. So I'm going to substitute for r squared, x squared plus y squared. And then for r, I can substitute root x squared plus y squared. Now I did what I had to do. I converted to rectangular form. This is fine by me if you leave it like this. Okay, you're good. You can simplify further because this is the same thing as x squared plus y squared to the 1/2 power on the left-hand side. So this simplifies slightly into x squared plus y squared. When you are multiplying exponents, okay, you simply add. So this is x squared plus y squared to the 3/2 equal to 3x squared minus 3y squared. Again, you can leave the original as it was, but let's say this is a matching or multiple choice, then you want to get, you want to match the most simplified form to whatever I give you, which would probably be the most simplified form. Okay. All right, let's move on to converting from rectangular to polar. So we did 2 examples, and those were to convert from polar. How do you know it's polar? Because you have an r and a theta. To rectangular. Let's try another example where we convert. So title this example 3. Convert from rectangular to polar form. Okay. So let's say I gave you A. Convert y equals x squared. You know what that is. That's a parabola. So what does a parabola look like in polar form? And then we are also going to convert B to xy equals 1, which is really y equals 1 over 2x, irrational. So let's see what that looks like in polar form. You want to give it a try? Go ahead and you try.